Yeah, so this is just the Euler's method. You can use this formula, and y0 is 1, x0 is 0, and you could just put that in there using a step size of 0.1. And you have to do it 2 times because it's asking you for y2. On the white cas, there's the sequence and series function. I'm not sure about the other cas. And that's question 11. Question 12. Oh, it's a slope field. So the first thing you look for is if there's a constant line of slopes, either in horizontal or vertical, but there's not, because it always changes. There's not a constant line anywhere. So you know the differential equation has to be both x and y included. Doesn't really help for this question because they all have x and y. But then the next thing you look at is where dy dx equals 0 and where dy dx equals 1. I mean, when it's undefined. So undefined is the easiest to look at because it would be a vertical line. So there's vertical lines here. So that means when y equals 0, because it's the x-axis, dy dx should be undefined. So if something's undefined, the denominator of a fraction is usually how that happens. So since AB don't have fractions, that means they can never be undefined. So it can't be A and B. And C is also wrong because it has to be undefined when y equals 0, not x. So it should be something with y on the bottom. So it has to be D or E. And then you can just look at the different quadrants. So in this quadrant, x is positive and y is positive. So, and that makes sense because the gradient is also positive everywhere. And if you look in this quadrant, y is positive, but x is negative. And again, it makes sense because the gradient's negative. So that would suggest that E is the answer, because if it was D, then the first quadrant, y is positive, x is positive, and then there's a negative. So the dy dx should also be negative. And for this one, it should be the other way around. But it doesn't match with this slope field, so it's E. It's question 12. Question 13 is a rates question, so it always helps to draw like a container or something. So it says, so water containing 2 grams of salt per liter. So in goes dq dv is 2 grams per liter. And at the rate of 10 liters per minute. And initially there's 50 liters of pure water, and it's pure water, so there's no salt, so it's 0 grams. And then it's being stirred, and then it's coming out at 6 liters per minute. So the total dV dt would be plus 4 liters per minute. So the volume here is equal to 50 plus 4 liters per minute, where t is how many minutes. And it's asking for dq dt. So for this side, dq dv is just q on v, which is this one. So 50 plus 4t. So combining these two, you do dq dt is dq dv times dv dt. So you just multiply these two and you get 6 on 50 plus 4t. And to get dq dt in, you do the same thing. So it's just 2 times 10, which is 20. So the total dq dt is dq dt in minus dq dt out. So this is dq dt in grams per minute, and this is dq dt out. So you just do 20 minus 6 on 50 plus 4t. That's not an answer because obviously the fraction's been simplified. So it's just 20 minus 3 on 25 plus 2t. If you just get rid of 2 from both the numerator and the denominator, and the answer is A. Next question is question 18. So this is just converting between like the differential equations. So you have an equation with A and V, but the conditions that are given are V and X. So you know you have to get rid of A and you have to rewrite it as V and X. So the only two things you know are dV dx or A equals half dV squared dx. I used this one just because this one also had V squared in it. So it looked easier to me, but it should also work if you do this one, but you might have to do substitution because like you'll get V on V squared minus one, and then you'll have to use V squared minus one equals U. But in this case, if you use V squared, it's kind of already substituted for you. So you just use that one, and then half dV squared dx equals V squared minus one, and then you can rearrange it. So you get 1 and 2 V squared minus 1 equals dx. And this is kind of like your square root function. Like if you do d dx, you just get 1 on 2 square x minus 1. So you kind of know that's already V squared minus 1. Plus C equals x. And then you can sub in the initial conditions. So 2 minus 1 plus C equals 0. So then C equals minus 1. So if you put that into here, V squared minus 1 equals x, and then all the answers are in V in terms of x, so you have to rearrange it, equals x plus 1 squared, and then V squared equals x plus 1 squared plus 1, so you could just square root it to get rid of the V squared, and it's D. Question 19, so yeah, with the dynamics questions, always good to draw a diagram. So there's a hot balloon. This is rising at 2 meters per second, and there's a camera, and this one falls 100 meters to the ground. Ignore air resistance, and it's asking for time. So we have we have U, which is 2 meters per second going up, and we have S, which is 100 meters going down. So I'll just write negative 100 meters because displacement's not a scalar value. And we know A, which is negative 9.8, negative 9.8 meters per second squared. And we need to find T. So the equation that doesn't have V in it, because we don't know what that is S equals UT plus half AT squared. Then you can put these values into here and solve it like a quadratic on your CAS. And then I think one of the values is negative, so you get rid of that one because time can't be negative, and you just get C. Question 20. So there's a lift. There's a 5 kilogram parcel, so the weight force is 5G. Then there's a reaction force, and the whole lift is accelerating downwards at 3 meters per second. So we have to use Newton's second law here. So F net equals ma. So since it's going down, it's F weight minus Fn equals 5 times 3. So F weight is 5G minus Fn equals 15. And if you rearrange it, you just get 5G minus 15, which is 8. Question 21. So another particle it's 2 kilograms this time, and it's moving with a velocity of 20 meters per second. And there's a force going this way. And it's asking how many newtons that force is. So we have a change in velocity and we have a time. So if you have a change in velocity, that kind of implies you're dealing with momentum, especially because it's by itself and it's asking you for force. So the equation with momentum and force is impulse equals F average times time. So impulse is P, I'm just going to M delta V equals f times 4, so f equals 2. The initial velocity is 20. Oh, no. Yeah, so the final velocity is 2 and the initial velocity is 20, so it's negative. And that makes sense because the force is opposing the velocity, so that makes sense that the answer is negative. And divided by 4, so it's just half of 18, which is 9. And it's only asking for the magnitude, so it makes sense that all the values are positive, but in case they had like negatives to trick you or something, important to read the question. So question 22, last question, it's saying that there's a mass and it's falling towards the earth, so it has a weight force, but it's slowed by air resistance, and that's, just write friction, and that has newtons kv squared, newtons, and v is the velocity, so it's going down with v, and it takes, where v is and after that's 2 seconds. So this is just F equals ma again, so F net, since he's going down, F weight is minus Fr, so and equals ma, because we don't actually know what F net is, but it's asking for an equation of motion, and you can kind of see that all of the answers are like they're how you write a in a differential equation, like a equals dv dx times v or stuff like that. So you can see, like, from the answers you can kind of tell what to do in the question. Yeah, so F weight is mg minus kv squared equals ma, so a is mg minus kv squared on m. And a again is one of those two things, half dv squared dx or v dv dx. In this case, we don't know which one it is, so we can't only use one of them. But so it's kind of where you have to look at the answers because you're kind of like stuck a bit. So this is either equal to this or this. Immediately you can tell it's not a, because if you simplify the fraction, it's kv squared on m. Oh, sorry, I forgot. It can also be dv dt. It's a bit unlikely though because it's given in v, but technically we don't know if v is x or t. But yeah. So it's not a because this should be divided by m if it was a. For b, again, it's missing a mass here because otherwise it would be like if you multiplied m here, it would be this one, but it's missing this mass, so it's not b. C is trying to use this equation, but the 2 shouldn't be on the denominator. The 2 should be in the numerator, so it's not C. D is trying to use this equation, but it somehow has a 1, so it's not that one. And E is dv dx, but it's missing a v. So if you so v dv dx would be this, but they got rid of the v, so you have to divide both sides by v to check what happened, and then you get the rest of what they give you. So E is the answer. Yeah. So this question's kind of like using the answers to, like, you kind of go answers to question, and then you have to go back from questions to answers. It's a bit, yeah, it's a bit like that. Short answer, question 3. Question 2. Oh, this is question 3. Yep. So verify by substitution that ln equals this. So we have dn dt. So what we do is we can, since we have to verify by substitution, we have to find dn dt. So we take ln 6 minus 3e 0.4t, and then you do impdiff. And then you can, like, you can just tell that it's going to be 1n times dn dt. 6 is a constant, so it's 0, and this is in terms of t, so we don't get n dn dt, we just have this. And if you rearrange all of that, you get dn dt is 0.12n e 0.4t. So we have this now, and we also just know that ln n equals 6 minus 3 0.4t, which is helpful because that's the exact same term in the expression we need to verify, so we don't have to like get n to the power of e to this thing, because that would be a bit complicated. So yeah, so we have 1 on n times dn dt plus 0.4 ln n minus 2.4 equals 0. So left hand side, and we want to substitute 1 and 2. So 1 on n times 0.12n e to the 0.4t plus 0.4, and then ln n is actually 6 minus 3 0.4t minus 2.4, and then you can kind of tell that the n's will cancel here, and this term will cancel with this term. So I'll just write it out so you can see. So 0.12e negative 0.4t plus 2.4 minus 0.12 minus 2.4. Yep, so you can see all the terms cancel, which is it's a good sign because you know you've done the right thing. And yep, it's just 0, which is what you wanted, so you're correct. And it's asking for the initial number, so that's just when t equals 0, so ln equals 6 minus 3e 0.4t, and if you let t equal 0, ln n equals 6 minus 3e to the power 0, so ln n is equal to 3, so n is equal to e to the 3, but it's asking for the integer, so if you put that into your cas, you get 20. And now it's asking find the limiting number of mobile phones that would eventually be earned. So limiting number of mobile phones means like eventually it's gonna like plateau, so it would become a constant value. And when that happens, t would go to infinity. So you take the ln equals 6 minus 3e negative 0.4t, and you let t go to infinity. So if t goes to infinity, like the graph of e to the negative 0.4t kind of looks like this. So if t goes to infinity, this value will go to 0. So this would become negative 3 times 0. Yep, so this is just ln goes to 6. So n goes to e to the power 6. I should write arrows. E to the power 6, and e to the power 6 is like, again, because it's asking for nearest integer, it's around 403. So that's how you do that one. I was thinking about doing it a different way. I might test it right now. I was thinking if it's gonna plateau, then dn dt would eventually go to 0. So dn dt is actually n times 1.2 e negative 0.4t. So this is e 6 minus 3e, oh, this is complicated, times 1.2 e. Yeah, I don't think you can do this method because neither of these values will go to 0. Actually, yeah, they won't, but again, if you basically have to do the same thing because, yeah, so don't do it this way because you're basically doing it the other way but longer. Part D, so it's asking d squared n dt squared, and you have this one. So we can't use any of the flip rules because it's otherwise you might get like dn squared instead of d squared n. So you have to empty this again. So 0.4, and then you have to do dn dt of n 6 minus ln n. Just write dt squared. So 0.4, this would be, I wrote it wrong. It would be d dt of that phrase. So it would be dn dt 6 minus ln n. And then you have to do the product rule. So n and then 0 minus 1 on n times dn dt. Right. So if I simplify that, dn dt 6 minus ln n, you can see that these kind of cancel, so it's just times negative dn dt. So if I take it out, like factorize it, I just get 0.46 minus ln n times negative, sorry, dn, dn dt whole squared. So this term is different from this term because it's like this one's you differentiated it twice, but this one is you differentiated it once and then you squared that you squared that answer, and that's important because we actually know the expression when you square it once because that's this one. So we can substitute this into here and you just get negative 0.46 minus ln n 0.4 squared n squared 6 minus ln n squared. This is not how I did it before. I might just go back. Oh, I forgot the plus. Sorry, that's why. So it's plus, not multiplication. So it's minus dn dt, and then you have to substitute that in. So equals 0.4, or you could factorize it out, I guess. Dn dt, and it would be 5 minus ln because this would be 1 when you take it out. So if you substitute this into here, 0.4 times 0.4, so 0.16, and then n 6 minus ln n, and then 5 minus ln n, and that's it because you have your answer in terms of n and ln n. Now it's asking, it has a point of inflection, and you have to find the coordinates of the point. So point of inflection is when d squared dt squared n equals 0, and it's helpful because that's what this is. So d squared n dt squared equals 0.16 6 minus ln n 5 minus ln n. So when you let this equal to 0, n equals 0 or n equals e to the 6 or n equals e to the 5 just by like null factor law. And can't be this one because the graph starts at here. Like, oh, sorry, no. This is n values, not t values. N is not 0 because t starts at 0, and when t starts at 0, the graph like looks like this. So n is never 0, so it's not this answer. When n is equal to e to the power 6, that's actually the answer from here, this one. So this is not a point of inflection. That's just when the graph starts to plateau, like just starts to become flat. So it's not that one. So the only option is e to the power 5. So n equals e to the power 5, but it's asking for a t value as well as an n value. So you have to use your initial equation, which is ln n equals 6 minus 3e negative 0.4t, and you just put that in here. You can use your CAS to do it, or you can do it by hand. It's not that complicated, but it is like a extended decimal answer. So CAS is probably the best idea, and you just get t equals that. Oh, and the graph just looks like, so you have to put in all the points that you got. So at t is equal to 2.7, so that's like here, and n is equal to like 148, so here-ish. That's the point of inflection, and from the very first or second question, when t is 0, n is 20, so when t is 0, n is like 1, 2, 3, 4, n is here, so you have to kind of make it look like, oh, and also it plateaus here, so make sure it doesn't go past this point. So like this, kind of like that, yep. And just label the points. I think this was 148. I'm not quite remembering, but oh no, wrong way. And 0.20. And that's question 3. So question 5. What's this one? So this game determine the min and max speeds of the water skier. So you have the position equation. So to get speed, you have to differentiate it and then mod it. But first you have to find the velocity equation. So you have to differentiate it. So it's just 7.5 and constant is 0. So sine goes to cos and the chain rule. So it's just 7.5 I minus 5 pi on 3 cos pi t on 6. And to get speed, you just mod the velocity so that it becomes a scalar value. So 7.5 squared plus 5 pi on 3 cos pi t on 6 whole squared. And you can simplify this on your CAS to 5 on 6. 4 pi squared cos squared pi on 6t plus 81. And there's a function called f max and f min, and you can just put that in here. I put my boundaries as 0 to infinity, and the min speed was 7.5, and the max was 9.1. You could have differentiated this and equated it to 0, but I use this method because just in case the maximum and the minimum aren't at a stationary point, which was actually, I think, what happened here, because the maximum was at t equals 0, and I don't think that was a stationary point. So if you do this method, it's always good to check using like a graph or these functions that the minimum and maximum are actually at the stationary points, because like if it's like a weird cubic graph or something, like they would say that's the minimum, but the maximum, but the maximum would actually be like infinity, or like this would say that this is the minimum, but the minimum would actually be 0 or something like that. Find when the acceleration is 0, so at is r dot t, so it's again, we found rt from here. Constant goes to 0, and then cos goes back to sine. So 0I plus 5 pi squared, 18 sine pi on 6t j. So if acceleration 0, this thing is also already 0. So the only like part left is this part. And if this is going to be 0, then the sign is going to be 0. So sine pi 6 on t equals 0. And like the unit circle, the only time sine is 0 is when theta is equal to 0 or pi. So you could write that as pi on 6t equals to pi n. So t is equal to 6n. And n, since we're talking about time has to be greater than 0. So n has to be an element of the positive integers. But you could also include when n is 0. So you have to include this. But the answer guide, I'm pretty sure, said you don't have to include the 0 part. But yeah, it didn't say anything where like you couldn't, but I guess I don't know, maybe they just accepted it. Yeah, so C is this guy going up a ramp. This is just equations of motion because the speedboat slows, but it keeps the water skier's speed at this speed. So it's constant acceleration, but also F net equals 0 because there is no acceleration because the speed is kept at this one speed. Yes, that's how you know you're supposed to use constant acceleration formulas, because if you like try to use F net or something, it's equal to 0, so that won't be much help. So things we know are he starts at so this person's actually here right now, and he's like about to fall into the water. So since the speed is kept the same, like u here equals v here, but the v here would be u for this journey. So I'm just gonna call it u, and this this v is not equal to this u, so we don't know that. The distance is 10 meters. Oh no, sorry, it's not 10 meters. So this is the height. So the distance is 10 times sine 30 because of like Pythagoras, or I mean not Pythagoras, just trig, because sine is opposite on hypotenuse, so you can figure out the height. So that is 10 sine 30, which is just 5 meters. We don't know v, but we do know a, so it's negative 9.8 ms minus 2. We don't know we don't know v, and we also don't want to find v, so I just write it as x. And we don't know t, but we want to find t, so I wrote a question mark. And just like that other multiple choice, you just do this equation and you sub these in, and then you can find t like a quadratic, and it's like 2.03 seconds, if I'm reading my handwriting correctly. And now it's asking horizontal direction. So since there's no acceleration, it's just speed equals distance over time. So distance is speed over time, and speed from here, like if you 15 this way, the angle's kept at 30, like the instant he leaves off the ramp. So if you do vector resolution, it would just be 15 cos 30. So distance is 15 cos 30 times, since it's the maximum horizontal distance before hitting the water, we need to know the time it takes for them to hit the water, and that's what we calculated here. So it's just times 2.03, but it's best to use all the decimals. But in this case, it doesn't matter because it's asking to the nearest meter, and you already have 2, but like just a good habit to use the decimals. Yeah, something close to 26 meters. Since the question kind of changed, it helps to draw a new diagram, kind of. So the angle is still the same. We don't know what the mass is, but there is Fn, and there's always Fw. And there's also friction now. So it's asking to find the distance up the ramp. So if it's the distance of the ramp, then we're going to have to use our constant acceleration formulas at one point. But before we can do that, the only things we know right now is that u equals 10 ms minus 1. Don't know what s is. We know it stops, so v equals 0. And we don't know what time is. So we either have a choice, and we also don't know what acceleration is. So we either have a choice to find time or acceleration, but given the information we have, you can kind of tell that we're going to end up finding acceleration, not time, because what we have are the forces, and when you have forces, like the thing to use is F net equals ma. So since it's traveling up, Ski is traveling up, but actually he let goes of the rope, so there is no force going up. So all the forces we have will be negative, equals ma. So the resolution of the weight force is just mg sine 30, and the resolution of the friction force is mu of the weight, the normal force, and mu is 1.81 on 8 root 3, and the normal force is mg cos 30. And you can see why they didn't give you mass, because it would cancel out anyway. So if you simplify this, it's g on 2 minus g on 16 equals a. So a is negative 9 on 16. Oh, sorry, 9g on 16. So now this we know is that value, where g is 9.8. So now we can use the one constant acceleration equation that doesn't require time, which is v equals u squared plus 2as. And we're looking for s, so you just rearrange it. Then you just put all your values in and you get 9.07, I think. Oh, no, sorry, it asks for 1 decimal point, so 9.1. The last question is saying that the water ski is coming to a stop on the ramp, and now it's asking for the coefficient so that he doesn't slide back down. So if he's not sliding back down, what we know is that friction opposes motion. So if he's sliding down, the friction will be going up. So basically, if that's not to happen, then the friction force must be greater than the weight force. And the friction force is mu of the normal force. So we can rewrite it, and again using like this diagram, which is why it's important to draw a diagram, because it helps later on. Is mg cos theta is greater than mg sine theta, and the mg's just cancel, and like if you divide by cos, becomes tan. So mu has to be greater than 1 on root 3. Asking for the minimum one, so the minimum one would be when it's neither sliding up nor sliding down, it's just at a stop. So that would be when mu is 1 on root 3. Yep, and that's that question. And that's the last